Yeah.
Hey, good morning, everyone. Welcome in. I'll give you a second to set your audio settings. I will also be launching a poll here just to kind of get us started. So if you guys want to go ahead and answer that, that would be awesome. Perfect. Well, thank you for joining us here today. As you know, we come together to talk about a major concern, obviously, that's impacting everyone across our industry, and start unpacking how to really reduce utility line damages. My name's Lily Kolish. I'm the Director of Product Solutions here with PointMan. My background is in quality assurance engineering and field testing, and my current position allows me to leverage my product knowledge in the field and implement new workflows to help companies reduce line strikes and damages across their projects. I have with me my colleague Peter. Peter, if you'd like to introduce yourself.
Certainly. Thank you, Lily. My name is Peter Schreier. I'm the Chief Engineer here at ProStar. By background, I'm a professional engineer and a licensed land surveyor. I have about over 20 years experience basically in field operations, ranging from anywhere from the high Arctic to South American jungles. And several years ago, I pivoted back into the kind of the technology industry and have been working with companies on geomatics projects, machine learning, AI, and that kind of thing. And I'm very happy to be presenting to you today on GPS corrections and how they impact the utilities.
Awesome. Thank you so much, Peter. And from PointMan Navigation, joining us on this webinar, we also have Gabe Amencio. Gabe.
Yeah. Hi, everyone. Gabe Amancio. I am our head of application engineering here at PointMan, which means I typically just have this expertise in precision GNSS and localization as a whole. I typically am applying our corrections to a ton of different applications across a lot of different industries. So I get the pleasure of working across a ton of different technologies and applying corrections to each of those. Prior to PointMan, I've received my bachelor's in electrical engineering from Cal Poly San Luis Obispo, and actually honed kind of my skills in the semiconductor industry, focusing on sales and application engineering there as well. So excited to speak to you all today.
Awesome. Thanks so much for that, Gabe. So accurate utility mapping is it's a crucial and often overlooked aspect of every infrastructure project. Every year there's thousands of line strikes. There's a line strike every working minute of every working day. And oftentimes that's due to inaccurate, outdated location data. These lead to costly damages, project delays, and obviously, most importantly, safety risks. When you send a guy out to the job not knowing where a high pressure gas line is and you have an excavation crew out there, that's posing a major risk on the lives of your crew and other, bystanders and civilians as well. So, in order to understand, obviously, how we're to reduce some of these line strikes, we need to understand why they happen so frequently. And one major reason is the limitations of traditional mapping methods. Many rely on outdated records, incomplete data sets, or inconsistent surveying techniques. This leads to gaps in utility location data, increasing the risk of accidental strikes. So to put that impact into perspective, the line strikes cost the industry billions of dollars annually, not just in repairs, but in liability claims and regulatory fines and lost productivity. We can't even put a number on how many line strikes occur during each job because each job is so different. But if you look at a major construction project in a major city like Los Angeles or Denver, we're talking about thousands of strikes during the duration of that process or of that project. And beyond the financial toll, obviously, there's the serious fatal safety risks as well. So in an effort to help reduce these strikes and the impact they have, Gabe, how do you see inaccurate or outdated utility location data contributing to line strikes, and what challenges are companies facing in improving their accuracy?
Yeah, I think specifically with utility management as a whole for the mapping side, one of the first non-negotiables really is to have correction data in order to align, that data down to hyper precise accuracy. The issue that comes about that is potentially the different sources that you could be pulling from for that correction data, and having different alignment of your data, whether it be data misalignment, having, like you said, kind of old records of your maps, or not just having consistency in your correction data. And there's a large issue that has been there for a while where, you're piecing together different, correction networks that may have, different alignment of their data. And then you go to a site and you're, operating on a different correction service that you had mapped upon. And then all of a sudden you have, meter and a half shift, something like this that can, be fatal to your operations, your projects. So that is one of the biggest ones, is the discontinuity in corrections network that we see, and kind of the misalignment of data as well.
Absolutely. Peter, I didn't know if you had anything to add to that.
No, Gabe does a very good job of stating that. I mean, the alignment is the biggest issue we have. I mean, we get all sorts of, for us at PointMan, questions on this correction service or this correction service, and there is a large disconnect in how well they're monitored, how well they're set up, and how well they're supported. And that's something we really need to address, throughout the industry.
Absolutely. So taking a step back and just kind of explaining this as a whole, Peter, I know that you have a couple slides here you want to go through. So if you can see my screen, I'll let you take the floor.
All right. Well, thank you very much, Lily. I appreciate that. Yes, as Lily said, we're going to, take one step back. We're going to check your screen there, Lily. We're going to, look at the basics of this. How do we get an accurate position on a GNSS system? The idea here is when you look at your phone, I mean, I know everybody looks at that and thinks it's, accurate to within a few inches. It is not. Technically, it's only accurate to about 3 to 5 meters. It may give you an indication that this is far better, but it is not. That's usually an indication that is misrepresenting precision as accuracy, or vice versa. There are two different terms there. Next slide there, Lily, please. So essentially, there are many GNSS error sources. I'm really going to go through these kind of 6 or 5 or 6 here that are the major components of this. I'm not going into the relativistic ones because those are a little more complex and are also solved in a lot of cases using a correction service. I mean, the biggest issues we always have with GNSS corrections, no matter what the constellation, is atmospheric. The two pieces, the troposphere and ionosphere. The troposphere, anything below approximately 10 kilometers, thereabouts, is actually quite well modeled. It really kind of goes against conventional wisdom because the first 10 kilometers being highly water-based. So there's a lot of challenges there, but it's actually very well modeled. The biggest error sources we get are from the ionosphere, from 10 to about 100 kilometers. The reason for that is subject to a lot of the solar activity. We get notices of solar flares coming across, and in my industry, that is a big thing to see. You got a G2 flare coming across, you just know that the next day is going to be a terrible day for GPS. And problem is, most people don't notice that, don't see it, and they go on with their work. You have a correction service, it will mitigate a lot of that, but not all of it. I'm going to be honest with you, but it is designed to do that as well as possible. You got things like multipath. Generally, we can mitigate a lot of that just by antenna design or placement of your GPS. In some cases, GPS placement is where it is. We have to get that position. Ideas of satellite geometry. GPS, sorry, I should restate that. GNSS systems are a trilateration system. That is, you get your position relative to the position of the satellites, the distance from them. So by that measure, you have to know where the satellites are. GPS satellites travel at 4,000 meters a second. So they're moving fairly quickly, and so you have to be able to understand where they are and how precise that is. That directly affects where you are going to get your position. You got things like orbit errors. Now, again, if you need to know the position of satellites, you need to know where the orbits are perturbating, and you also have what's called receiver noise, which causes some signal processing errors. These are the kind of the major effects, and these are the things that a correction service will be able to mitigate for you. Next slide there, Lou. Right. Just a very quick understanding why we need correction service. You need it because if you don't have it, your accuracy of your GNSS position is 3 to 5 meters at best. Could be farther, could be worse. We never know. The biggest issue there is it may not be consistent. It will jump all over the place. So we have precision and accuracy requirements for that. And that is what we needed. I mean, if you're just driving down the road with your car GPS, well, let's be honest, it doesn't matter. This is not what we're referring to. If you want to find out where that gas line is, you need accuracy to within a few centimeters. That's exactly what we're trying to do here. So you have consistency, you have reliability, and you have accuracy. Yeah. Next one there, Lily. So really, there's two broad categories of how you get correction services. Either getting from a satellite-based system or a ground-based system. This is kind of a higher level overview of it. When most people see SBAS, satellite-based augmentation, they're actually thinking about what's called WAAS, Wide Area Augmentation Service, or EGNOS, which is what happens to be in the European market. These are not necessarily the high precision systems, okay? This is something that even your phone is getting. But you can also get correction services over a satellite, and my colleagues at PointMan Nav will go over that as well. But I'm just showing you these are two ways of getting the correction service, delivered to you, if you want to call it that. Ground-based system, something like a standard base rover pairing, ground-based system. It's localized and uses what it is. But most ground-based systems are very tightly tied to what they're doing. You have aviation applications, which are based at the airports and designed for landing aircraft. You're not going to be getting those correction services. Those are specific. And there's very specific areas where these are done. Okay, next slide. All right, so realistically, this is kind of the main thrust of what the different type of correction services are. You have RTK systems and precise point positioning system. I'm going to push it into those two categories based on the fact that one is near real time and one isn't. Precise point positioning is if you're in the middle of nowhere, you have no communications, you have no base stations around you that are already established. So you push down your own GPS as a base, you started collecting, and you leave it and you go off with your rover. Okay, that's one way of doing it. I've done that hundreds of times up in the high Arctic. There is no way you're going to get communications and there's no base stations. Essentially, you're establishing a base station post-processing. You set it down, you collect for a couple hours while you go with your rover. You take your Rhinex data off your base station, post-process it. NRCan has a position system that does that for you for free, and then you readjust everything based on that. Perfectly fine, you can do this. It is not real time and requires a significant expertise to understand how to do this. PointMan Nav has the ability to give you or model these PPP systems. It is a database that you're getting ionospheric models, orbital parameters, clock parameters, et cetera, et cetera. But again, I'm going to tell you, this is a significant undertaking and nothing to do with real time. You will not get real time this way. So the other method, RTK, real time kinematic. Static being the same thing as this, it's just if you're moving or not. Now, there's several types of RTK, whether you're using your own base station and you set up and you have a single baseline, that's perfectly fine. Or you have a service that will transmit via radio, via satellite, various internet ways of doing this. This is an RTK system. This is the most precise way of doing it. The issue here, good thing is it's real time and it has no convergence time, which means you set it up, start running and go. But you have to be near a base station or near the base station that is transmitting these, okay? Network RTK is kind of a, same as an RTK system, but you may have multiple base stations around. It's very simple. You can go from site to site within the area, and it uses the same principles. The issue here is you may have some, 2 to 3 minute convergence time. Convergence time is not because it's booting up or doing anything like that. It means you have to get enough observations to enable the Kalman filter to set up the models for the ionosphere and troposphere. It is a factor of physics here, and all correction services will have that. The other idea is you have a more global system, in which case you still have a little longer convergence time, but you can go from point to point, possibly continent wide or country wide in a consistent manner. In the cases like this, they use what's called a SSR, which is a state space system, which allows you to model the errors over a larger area. Okay. Next one there, Lily. So, forgetting all the complex problems of setting up a correction service and how it works and what you have to do to get it, I'm going to, give you an idea of what does it take to set up a correction service. I mean, as a conglomerate or a company who's actually pushing out these correction services, it's a little different than if you're setting up your own base station, but the same principles apply. You need to understand that you have to have constellation support. By that I mean Galileo, GPS, Beto, all the different constellations. Are you going to be receiving those signals and processing them? It's a lot of challenges for you to do. Are you getting all the signals? L1, L2, L5, E6, E2. All those have to be understood and understand what you're doing. And more importantly, and this is the biggest thing I always see with a correction service and I look for, integrity and monitoring. I want to be able to know if something goes down. As an engineer, I hate surprises. If I leave the field and come back in the office and recheck something and I realize I was off by 3 meters, I'm going to be very annoyed. I don't mind if you tell me, oh, look, for whatever reason, X, Y, Z, for the next 10 minutes, we have a problem. Fine. I'll go sit and have a coffee for 10 minutes. But that is a critical piece of something we need to look at. Is this going to tell me if something's wrong before I leave the field? I've been in field operations where getting back to the office is a 2-day affair. I'm not going back there for any particular reason. Okay? Continuity. I look at this, and as Gabe has mentioned this, and we'll probably go over this a little bit more in a few minutes here, the ease of use. What you want to be able to do in the end is say, okay, my correction service is PointMan app. Click the button, let's start, let's go. I don't want to have to sit there, figure out parameters, figure this out, and see what's going on. Oh, wait a minute. I'm 1.5 meters off. Okay, that's a datum issue. I have to look at that and change that. Okay, those are something your field operations are not going to want to have to deal with, and they're probably not going to deal with it. They're going to ignore you and carry on. Okay? And the last thing here, availability. Can I use it in all my field operations? Can I use it in Colorado? Oh, wait a minute. I need that subscription for my operations or project in California. So those are all issues that we want to look at for a correction service, notwithstanding the fact that, all the accuracy requirements that we have to go on. Yes, with that, I'm going to pass this off back to Lily, and we can, go to PointMan Nav, and they can show you their amazing system and how we've integrated that.
Peter, I appreciate you running through all that with us. Gabe, I know you have a couple slides here as well, so I'll let you take the floor.
Yeah, and thank you, Peter, for framing all that. I think you've positioned it very perfectly and what the problem kind of in the correction space has been and what we've really tried to bring forward as a solution to kind of solve those 4 points that you kind of just brought forward at the end. So just to talk to them, accuracy, system integrity, monitoring, continuity, and then availability. So I'll kind of talk through these next couple of slides. But yeah, what we have done at PointMan has been, we've kind of deployed and created the world's largest professionally managed independent RTK network that we privately own. And, we now currently have over 2,000 base stations that are a part of our network worldwide, and that spans 5 continents. North America, Europe, Asia, Oceania, Africa. We currently have over 150 million devices that connect to our network and have the capability to connect to our network, approximately 5 million that we're delivering to every single day. Peter, you mentioned the tracking of specific constellations and signals. We have our own base station that we create, which I'll go into, but to that point that I just want to touch, we do track all of the constellations, keep up to date with the latest firmware on all of our receivers on our base stations, make sure we track everything, and we're giving the best quality data to our customers at the end of the day. And in terms of the integrity side, I just want to touch to the top right. Obviously, when you have a connection with an RTK network, typically you're sending like a position, so then we can associate you to the closest space station and send you that data. One of the features of our product actually is giving you that visibility at an account level as opposed to just a device level. But again, to that point, we're not sharing that data with any third parties. We also have the option to do on-premise corrections, which is basically like giving you a container for larger customers to basically manage that portion of the location data on their own end and have no kind of back end to our side, so that there's even less concern of security if that is a concern in the future. Awesome. Lily, if you go to the next slide. Thank you. Yeah, and then just being a comprehensive solution, we really focused as a company from the very start. We've been around for about 8 years now, on the left side of our correction service product, which is true RTK. As Peter mentioned, this is true observable data from our base stations, one of the 2,000 that we have out in the world. And us as a company have really focused on building out this core technology and enabling people to have centimeter level accuracy everywhere. Within the last year, we did release our virtual RTK product, which is an SSR-based approach to corrections, which Peter did mention. The drawbacks to that, like you mentioned, are the convergence time is typically slower, whereas RTK is almost instant. This is typically like a 15-second convergence time. Also, due to the fact that this is a model based off of our physical base stations, you can only get so close to that centimeter level accuracy. So we typically quote that about decimeter. And then again, it's typically more, and this is across all SSR networks, typically more susceptible to some of these like solar events that Peter was mentioning, as opposed to the real observable time data that base station is broadcasting in real time, right? So there is some limitations there, but for the type of applications that we typically see in this space, we do recommend the true RTK just for that reason. But again, just to be comprehensive, I wanted to go over the whole list. The next one is satellite RTK, which again is based off this SSR model that we are able to leverage with our extensive network of physical base stations. And we actually deliver the corrections over satellite. So we take away the need to have cellular connection, which are required on the true and virtual RTK path. Again, accuracy is in that decimeter range. The z-axis typically has a little bit more trouble, and that's again just due to the SSR model. But to have the redundancy and the full solution package, we do have that available. And then again, PBK, we typically we do have a flow for the like PBK pipeline, but what we typically are providing is the RINEX data, which I think Peter mentioned previously, which is more of the observable data from the base station that you can then use to do this post-processing. Again, though, it's a fairly heavy lift, and then you have to take into account the time to post-process, which is one part of it, but then relying on the fact that there is a base station there that you'll be able to collect that data from. And if you are in these cases where you are out in the field, collect data over a day and then find out after the fact that there was no base station available, or this RINEX data isn't available, it's basically a waste of the whole crew's time, and just adds more cost to the overall project. So we try and solve that problem on the post-process side as well. But really what our focus is that real-time visibility from the network, so then that your mission is successful and you're able to move forward, and have that confidence in your accuracy and your position. Yeah, and right here, this is a quick image just of our base station, our true RTK base station coverage. This is available via our website if you're interested to have a deeper look into this. But just to comment here, we're always expanding our network. We work with many different private providers that we're able to like actually get physical locations to install our base stations. And then we have other models where we have commercial partners that are also expanding their operations. And we're always looking to expand our base station coverage. And like I said, our true focus at the end of the day and from the start has been, this physical base station that we can have everywhere in the world. And that'll actually lead in the next slide. Thank you, Lily. This is actually just like a little mock-up on the right of our base station. It's very small, the size of like a little toaster, basically, and very easy to install. But just to kind of talk to the reliability side of it and the reliability of the data and really the like system integrity part as well. So we have reimagined kind of like the base station design in our design, and really thought about like these 4 key tenets of like how can we really give that to our customers at the end of the day. So in terms of accuracy, every single base station that comes online are surveyed over like 2 days worth of data. And then we actually in our backend have constant surveying of every single one of our base stations. Not to say that we're updating, the position daily, but we're basically checking for any variance in the position if there's like any movement of our base station or actually movement of the actual ground. We're aware of that, and if there's any more than a couple centimeters of variance in our position, we're working to update that and make sure we're giving the best data available. On the positioning side, the second bullet there, I wanted to talk through, we have very high-end receivers that we are always updating and making sure that we have the best satellite availability ready for customers. We notice and see that a lot of customers may only have like a dual band receiver. So from our end, we need to make sure that we support everything. So if they show up with a dual band that is L1, L2, if we're a correction network that only supports L1, L5, that's not going to give them the level of accuracy that we need. So we make sure that we give the best corrections that we can available from our base stations. The communication side, we have dual SIM on every single one of our base stations, and basically have a network monitoring portion on our backend as well to basically swap networks as we need if we see anything on the network side, the cell network side, that could affect the actual connectivity to the base station, which is obviously going to be an issue. So we monitor all of that in our backend, and then power. We have an internal battery that'll actually last up to a week if it does lose power. We take wall power and also solar on every single one of these as well. So just the redundancy and the reliability is something that we really take seriously with our base stations, and just work on making sure we have as much uptime of these as possible. Awesome. I think that was it from my end. And we can go into, thank you.
Yeah, thank you so much, Gabe. I appreciate your comments on all that. So let's take a minute to pause after, that technical background conversation. I want to give you guys a second to, if you have any questions, feel free to post those live. The next section we're going to go into now is actually understanding the numbers. How are we reducing line strikes by 97%? I think that's really the question everyone wants to know. So those are some of the questions we'll be answering next. But yeah, I want to give you guys a second to post any questions that you might have, so that we can continue to answer those. And feel free, as we're talking, to post those as well. I'll be checking in throughout the rest of the webinar, and there'll be a question and answer session at the end as well. But perfect. Awesome. I'll give you guys just a few more seconds. Awesome. So really, to wrap that last section up, Gabe, how would you say adopting real-time, high-precision GNSS, GPS positioning can actually reduce line strikes?
Yeah, I really think adopting, personally, I really think the TrueRTK, like I mentioned, is kind of the right solution, just because of like the variability with SSR at times. In terms of even decimeter may be okay in some applications, but for the level of this requirement, I would recommend TrueRTK, but just really utilizing and kind of incorporating it from the very beginning of the workflow, I think is what's so important, which is what PointMan is really bringing forward to the industry, is like this consistent way to go about mapping, locating after the fact. And to that point, if you have that consistency across your correction service as well, to know that you have, the confidence in that centimeter level position, no matter where you're going, and are consistently using, the same sources of maps, corrections, it'll make everything much simpler, and then also kind of lead away from those kind of those data misalignments that we were talking about previously. So if you start it from the beginning and are constantly using this same source, it'll definitely push you away from having these types of line strikes, because then you're confident in the fact that you always have this centimeter level accuracy in your position.
I really like what you said at the end there, confidence, right? Confidence is key in all of this, because you can have, as many maps as you'd like, right? But if they're as-built maps going off of design records versus what I like to call like the as-constructed records, I would hope you're not, placing your confidence in that, because you're going to find your electrical line across the street from where you thought it was, right? So confidence is really key. I mean, I have people all the time who call in and say, hey, look, we just purchased this GPS system, and still our accuracy is, not at all what we were expecting it to be. We spent $10,000 on this unit, and we're only getting within several feet. And I'm like, yes, you're lacking the RTK system. So really what it comes down to in having that confidence is three key parts, right? You need the hardware to do the data collection, you need the software to do the mapping, and you need the correction service to ensure the accuracy of the data, right? So getting down to the numbers, we did a case study with a large, and I can't name names, but a large construction firm, one of the largest in the country, and a DOT in conjunction. We came in about halfway through the project because they were having issues with line strikes. Every day they were striking different lines, and I believe the statistic is there were 380 something line strikes within the first half of this project, and they were saying there's got to be a better way of doing this. And they implemented those three factors: GPS, correction service, and mapping software. And post implementation, we did reduce their line strikes by 97%. There was 3 total strikes. All 3 of those strikes were instances in which there was a failure to use one of the implemented systems, a failure to pull out the mapping software, a failure to connect to the correction system, or a failure to read the data. Oftentimes people, they're not used to having that high precision of data, in their hands. And so they say, oh, how can we trust it anyway, and go about their regular routine, right? But if you have confidence in the systems you're using, and when you're using high quality systems like PointMan navigation for RTK, you can hold confidence in that and confidently move forward in your project and say, the data that I'm looking at, I know I can trust. Now that's one example. That said, we have pulled handfuls of studies on multiple clients at random. Some have submitted for studies, and some we've just gone through and pulled numbers for. And every single one, the strike reduction is within the 90 percentile. I had someone call in recently and said, look, I know I'm asking for a lot, but I'm looking to reduce my strikes by 30%. And I said, let's try 3 times 30. I think we can do a little better than 30, right? So that's really what it comes down to. To answer your question, how to reduce line strikes by 97%, GPS, correction service, mapping. That's really the 3 key factors that fall down into that. So, and Peter and Gabe, I'll turn it back to you guys. But I want to hear from you guys what you think this partnership between PointMan navigation and PointMan brings that the industry didn't have before. And real quickly before you answer that, just in case you guys don't know, there is a brand new integration with PointMan navigation into PointMan. We're partnering up to provide real-time RTK straight into our mobile app. So it's going to be available at the touch of a button within the PointMan settings. So those of you who are already clients of us, let us know if that's something that you're interested in. We'd be happy to talk with you about that. And those who aren't, we're bringing, that accuracy, that confidence, all the much easier. I know in our previous webinar with radio detection, which I know PointMan, you guys work a lot with RD, that was a huge factor, right? We're bringing people into this conversation that, this is brand new to them. And so to talk correction service and have Peter go through his slides that are super, super important and very, very educational, they hear these big words and go, I don't even know where to start, right? So we're bringing not only the confidence, but the ease of use by saying, look, all you have to do is, go down this mapping software route and everything is at the tip of your fingers without having to be an expert in that field. So to come back around to that question, what do you guys see this partnership bringing to the industry that wasn't available before?
Probably first, what this means is ease of use, realistically. I've been in the field for many, many years, and I know the last thing I want to have to do is figure out, oh, geez, I need to know this data, this projection. Oh, wait a minute, this is my N-trip protocols, this, that, and everything else. I want to be able to turn the thing on and start working. I know being in the field that, usually you have 100 feet behind you is a big piece of yellow iron waiting for you to get out of its way. Okay, so you have to go, and you have to go very quickly, but you also have to, have confidence, like you said, Lily, in your work and what you're doing. This gives anybody using, the PointMan nav with PointMan confidence to say, okay, I'm ready, I'm rolling, and it's working. Confidence say, yes, it's working. I can see the data coming across. I can see the accuracy and, the metadata coming from the positioning. I am confident I can work now and go. That, ease of use is really what it is.
Yeah, and just to add to that too, I really like that, Peter. I think the other thing too is really the full end-to-end solution that's now provided too, with just the touch of a button. Literally, we'll have a little demo video, but it's so cool to see. It's literally just like connect with PointMan. It inputs all your credentials, auto associates you to your base station. Within seconds, you have RTK level accuracy. And I just want to talk to that side too of like the whole chain. It may not seem like that, but it's all really down to one step now. But what's actually happening is, we're passing our correction to PointMan. They're getting the data from the hardware and then applying these corrections and giving you this accuracy. But like to Lily's point, it's a lot that's already going on to simplify that and make it very easy to use. For the end user, they don't even see that, and it just works. And then you see, all right, I'm centimeter level accurate. I can go about my project and get going. So I really like the ease of use and full end-to-end solution kind of analogies of, for an end user, they don't need to know anything about RTK or anything about their hardware necessarily. They just need to know where they're at and how accurate that is. And that's what we're providing at the end of the day.
Absolutely. No, I appreciate you speaking to that, Gabe. Like you mentioned, we do actually have a demo of what it will look like in PointMan once you guys start using it. So Peter, if you'd like to speak to,
Sure.
what this looks like for everyone and how this is going to work.
Yeah, absolutely. So, this is your standard PointMan screen, and, the PointMan nav parameters have been set up by your project manager, and they're in here. And right here, all you see is what correction service do you want to use? PointMan nav. In your settings, that's all it is. Say, okay, yeah, the profile is this. All these things are in there, and basically you can't change them because these are what they are. And then you'll go ahead and say, okay, what do I want to do? I'm starting to survey right now. Seconds after I've showed this. Takes a few seconds to come across. Oh, look, here's my parameters. RTK float. Okay, waiting for convergence to come down. At this point in time, you are ready to survey, and you don't even know it. Now, as soon as that goes to RTK, you're set. Like Gabe said, a few seconds. You haven't had to do anything except hit that button and go. This has all been set up for you. And you also can see, your accuracies are there, your EPSG coming across, all the metadata that you need to be able to justify this accuracy in this position. There's quite a bit more than that behind it, but this is just what we're showing right now. But you'll see how easy it is to set this up and go. I think your field operations would be going, well, geez, that's nice. I don't have to set up a base station. I don't have to worry about, oh, how do I get the correction service across? I don't have to worry about radio or internet connections, setting those up. This is all done. Yeah, you see
Yeah,
right
to
there,
that point.
everything that you're putting. Yeah. Go
Yeah,
ahead,
to
Gabe.
that point, just the at least from our end as well. I just wanted to kind of comment because, like you said, there's typically a process of like finding the base station, figuring out like what's the mount point, all this stuff. All of that is done by our mount point and our endpoint. All auto associates, everything from that end is very easy to do as well. So
ideally, everything is, set up for you by the one person, possibly in the office that knows what they're doing, pushes that out to everybody else through the PointMan app, and off you go. And it doesn't allow your field operator to, for your point, change a mount point, which will cause, significant issues. This is what you're using. This is what you do. Go. So you're not going to get a phone call at 8 o'clock at night saying I have to go back in the field because my correction service my base station didn't work or something like that. So ease of use. This is what we're looking at here.
yeah, and that real-time visibility, like you said, Peter, is awesome. I think that's like a huge point of like the traditional way in a lot of these spaces was, using PPK, and then, if you get back and all of a sudden you're like, where's my data? You get that real-time feedback to see you saw the RTK fix happen, and you're collecting really good data to go with it. So
that's right.
My initial thoughts when we were watching that demo video was, this happened super fast. We need to slow down. I need to pause this video a little bit so they can see what the actual steps are. And then I thought to myself, well, no, this is real time. This is what it actually looks like. Like, this isn't sped up. This is precisely how fast it is to get that high precision data. It is just a couple clicks and they're running. That whole video from start to finish was your setup process. It was your connection. It was your data collection. And now it's your asset management. That was field to finish mapping with precision that now those records can be accessed with confidence for years and decades to come, right? So it looked fast to me at first, and I was like, no, that's just that's the reality of things these days.
Yeah, and what you also see in the background there is everything that you saw on the screen there. If you have reasonable communications, is also showing up in your back office. Your project manager back in Houston, Denver, whatever, will be seeing exactly the same thing if he wants.
Absolutely.
We don't support yelling at your field crew across the app, and that's just not going to happen.
We don't have the walkie-talkie feature yet.
Yeah, we're never going to happen.
So it looks like we've got a couple of questions here, and this first one, Gabe, I'll direct it to you. So Lawrence asks, based on the tremendous number of line strikes mentioned earlier, can PointMan be used to update outdated records? And PointMan, absolutely, but I'll let you speak to PointMan first.
Yeah, sorry, muted. There's definitely, I think I may have touched to it a little bit, but like, there are ways that you can go about converting your current data that you may already have. I don't know if I would recommend that, though, just because if you want to have the consistency across your maps moving forward and also operations moving forward, it's likely better to just like whether it's remapping or going about using our correction service and, like I said, mapping again. There are, like I said, other alternatives like coordinate shifting and stuff like this if you are operating on different datums. One thing I didn't note, which is probably important for this space as well, is we do support multiple datums via our different endpoints. So if you are using like NAD83, if you're someone in the US that does utilize that, we do support that. So even if you do have old data that may be different datum, different epoch, we can there's things that we can talk through to make sure that everything's aligned. But again, my recommendation is really moving forward and continuing to build new maps with these correction services to make sure that you do have that accurate data available.
Absolutely. So in my time in this industry, one thing that I've noticed is depending on specifically which field you work in, whether you're in construction or whether you're in oil and gas, utility owners, DOTs, etc., we use a lot of the same terminology, but with different definitions. So when they say, can it be used to update outdated records, right? That I feel like could mean a lot of things, which it could mean, what you talked to, which is, updating the current record set to include RTK accuracy. And oftentimes what we do coming into a project is we say, look, let's keep your current record set the same. We can import that data into PointMan so you can have it as what we call a reference layer. You can see that. Then you're going to take a new layer and do your new data collection. So you're updating your utility records, right? But you're keeping your old set of data the same, and you're creating a new set of data with precision. And then you can flip those layers on and off and view them either side by side or one or the other, and view the differentials or the offsets in between the two. One, for obviously, got to prove to the boss that we were out there doing something during the day, and these softwares are worth what you're paying for them. But also so you can see how far you've come in your records, updating those, and so that your field crews can have references to go off of when they are doing that data collection.
Yeah, that's really awesome. I wasn't aware of that. So that's a really good feature, I feel like, of the PointMan app too, and especially too. I'm sure I know me and Peter talked about it, but like people, we get calls all the time about datum and data misalignment. But having something like that basically gives you like that direct visibility of like, is there a shift? Is it like actually a shift, or is there actually an issue with precision, right? So that is awesome.
Definitely. And we have people doing, what you spoke to as well, Gabe, which is they take their old records and they're like, what's the purpose of having outdated data? And they using, the move feature in PointMan, you can actually update the current data set to have RTK. So regardless of what your workflow is, we're here to meet you where you're at. And not just with PointMan. If you're an ARC user, if you're using some sort of GIS or CAD system, we'll take that data in as well. So we want to, kind of play nice with everyone and be agnostic to, the different tools that you currently have and utilize in the field. Same thing with PointOne Nav.
Yeah, complete agnostic as well. We live on the software side as same as PointMan, and we want to make sure we're agnostic to hardware. Obviously, on the software side, it's very easy for us to do integration, which it's crazy how quickly we were able to turn around this like demo and release for this product, which is, I think, a testament to both sides of PointMan and PointOne. But yeah, and then on the hardware side, again, agnostic to make sure that we're supplying RTCM data that the receiver is expecting, and then they're up and running. So
absolutely. So it looks like we've got another question here. So Brent asks, getting centimeter accuracy and precision in XY seems doable, but EM locators don't have that level of precision or accuracy. So what can we expect for Y, or the vertical, and how can it be optimized?
Yeah, so to comment to that, typically with true RTK, so we still typically see on the Z-axis like 3 to 5 centimeters. I'd say actually typically closer to the 3 range on the Z-axis. One of the things that we notice with some of these SSR networks, which is why I wanted to bring that forward, we do support that as well, but typically the biggest hit in performance is usually that Z-axis. And that's just due to the modeling and the way that that model is created. We typically see that not across just our SSR network, other SSR networks as well that we've done testing. So my recommendation is really focusing on like that true highest level of accuracy. You're still going to have instances where you have like multipath, interference with the receiver, stuff like this that may still affect it. But in order to ensure the highest that you could possibly get, I think that is the best way to go about it, is using that true observable data that you can get from our network or other RTK networks out there.
Probably add a little bit onto that. You're absolutely correct, Brent, that your EM locator may not get, the Z-axis accuracy because it's basically a passive sensing system of the EM wave, and you're absolutely correct. But you're also not going to be, adding on inaccuracies. If your GPS or GNSS accuracy is 10 centimeters plus your RD, or sorry, your EM locator is another 10 centimeters, well, then you're propagating those errors. We aim to minimize, the errors that we can control. If you want the highest level of accuracy at, quality level A, well, that means you're going to have to dig it up. And that's what we allow you to do. Say, okay, this is quality level A because you had this metadata and we can prove your accuracy here, and you've uncovered it, whether you take a picture of it or not. So yes, errors will propagate. We are here to minimize the errors as much as we can on things we can control.
Absolutely. And I saw a couple of responses in that question as well. So those of you who are on the webinar who are commenting, I love the camaraderie. That's awesome. But yes, the RD2, let me try that again. The RD8200 SG is a great solution for that. So we'd be happy to put you in contact with someone over there. Again, we're agnostic, but obviously with our partnership with RD, we know plenty of names and numbers in case you need to get in contact with somebody. We have another question about studies done about utilization outside of the US. So for PointMan, yes, we have plenty of those as well. In fact, we have a large customer base in the UK as well as the EU, and some people popping up in Australia and New Zealand as well. We also have a few people running out of Mexico and South America. So, and a few throughout Central America. So we're kind of covering the whole globe in that aspect. We do only have a handful of true case studies on those, but plenty of client base. Gabe, if you'd like to speak to the PointMan Nav side.
Yeah, I can just kind of talk to the client base a little bit too, and just our expansion of the network. I did show a quick image of it, but we've been rapidly expanding. We originally focused on the U.S., being a U.S. company, but we have now covered basically all of EU. We have, I think by June of this year, we should have like 40-kilometer coverage basically of every single spot that you can find in the EU. Also by end of June, we'll have complete coverage of Japan, South Korea, and again, like Lily said, we have coverage in Australia and New Zealand. A lot of applications popping up in Australia that we've been noticing, and specifically this space. So we have the capability to expand there very quickly, and we have been keeping our eyes there. And then South America, we don't have coverage like PointMan, but also an option that we've been looking at for the coming future as well.
Awesome, thank you. So really quick, I just launched 2 more polls. If you guys wouldn't mind filling those out, there's a couple good questions in there, and we're always just curious to hear more from you guys about obviously who we're talking to, so we can better direct our webinars in the future to make sure that we're staying on task with interesting topics, things that actually are things that you guys want to learn about. Feel free to email into us as well, or check out our LinkedIn if you have any requests for webinars, any information that you'd like to learn in the future. We'd be happy to take some of those requests. So as we answer these last 2 questions, feel free to drop your questions in here and answer these polls. So Ken asks, do you partner with state available systems like Florida FPRN? Peter?
Sorry, I didn't catch that.
No worries. Do we partner with state available systems like
Yes.
State of Florida FPRN?
Yeah, we do. Any RTK correction is perfectly acceptable as long as it has, an end-trip protocol. We can carry on with that. I don't know specifically about the Florida one. I'm going to be honest with you. I haven't used that one, but I know here in Colorado, in Grand Junction, we support the free Mesa County Correction Service. I'm going to be honest with you. They work perfectly well, but know what you're doing and know how to set it up properly. It is not an easy press this button and go like we've seen here. You have to know your end-trip protocols. You have to know what data it's transmitting in, and you have to understand how that works when it's coming into your mapping software. Support it, absolutely, but you have to understand it. We can't understand it for you in this case.
Absolutely. And we've got one more. So Larry asked, what if we're already using PointMan and PointMan Nav and PointMan? There we go. Is that something that will be included with PointMan, or would we need to make any adjustments in our settings? So first off, love the fact that you're already using the solutions. Awesome. You get a gold star for today. But yes, really, really good question. So by default, this is not already included in your current PointMan subscription and setup. You will need to update your app to be able to see it. But I believe we have a specific process to set up your Point One nav inside of PointMan. So I'll touch base with you after this call, make sure that it's set up properly. But yes, absolutely, it's available for those who haven't, who are already signed up, but not in conjunction. Yes, we will be sending out a recording of this meeting to all attendees as well as those who signed up and weren't able to attend. A recording will also be posted on our LinkedIn. So if you had colleagues or someone else that in the industry who wasn't able to attend today, feel free to share that with them. Please allow a little bit of time for processing and just editing of this recording and whatnot, but we'll get that up as soon as possible. Really interesting question. So what's the impact to your bottom line of your customers when reducing strikes by 97%? The money's always, the key question there, right? So with strike reduction, obviously you are gaining more time on your job because you're not having to pause your job for the impacts of a strike, whether that's safety concerns or bringing in someone to repair that or not being able to dig in the area. You're saving a lot of time. Obviously, when it comes to impacting lives, you can't really put a price on that, but just know it's a high dollar amount. And third, obviously the direct cash flow involved with having to work on those repairs and the liabilities. So what we saw in the specific case study of the 97%, we saw that even at the enterprise level, they were using PointMan with over 100 users at that point. So we're talking, a higher cost than our base package. Significantly higher cost. It paid for itself in their reductions within the first 6 weeks. So that sort of impact on a bottom line is majorly significant, right? And that's just, we're an annual subscription. So if it pays for itself within the first 6 weeks, imagine the kind of cash flow that comes, in the 50 weeks following that, right? Gabe, I don't know if you have any sort of study you'd like to speak to.
No, I think that one was good for this case as well. I think you summed it up really well.
Yeah, I can probably add one little minor thing in there. Not just the actual monetary cost. If you hit something, you just know it's going to be on X the next day. And how would you like to see your project trending viral on a social media campaign so that even your CEO can see it, and then you have to discuss with him your incompetence, right? Monetary cost aside, it gets real embarrassing when everybody sees the mistakes you make. Look at that.
I may or may not have been guilty of resharing a few of those posts every now and again, but gotta spread the word.
Yeah, exactly.
I guess maybe the one thing I would say too is just time, but again, it kind of all goes hand in hand with all of that. But you touched to a little bit of like the process of how it's produced on using PPK, doing that, and it could be hours associated to processing this data that could be useless at the end of the day. So that time associated, I think, is huge to touch to as well.
Yeah, absolutely.
So we have another question here that says, so you can set up Point One and use nationwide with no additional setup?
Yeah. Once you're set up with your Ensure client and up with their credentials, once the flow is all set, connect anywhere you're at. Again, you would check the coverage map just to make sure. Again, we're always expanding, but most places I would say we have pretty well covered at this point. We're still continuing to improve that, but yeah, very confident.
Yeah.
Absolutely. Yeah, that is fantastic. Awesome. Well, we really appreciate you all being here today, taking the time out of obviously your busy schedules. If you have any further questions, feel free to reach out to us, via LinkedIn, pointman.com. We have all sorts of resources. Feel free to book a meeting with me. My meeting link is on my LinkedIn as well. So I'd be happy to have, a one-on-one question and answer session. If you'd like to check out a demo of PointMan, or even, speak to this conversation a little further and see some of these case studies and numbers, I'd be happy to send them over to you. Just reach out and I'd be happy to connect you with the right resources. Gabe, where can they find you in Point One Navigation?
Yeah, I'm on LinkedIn, so feel free to reach out that way. But our website is point1nav.com. I'd recommend, there's a ton of documentation. If you want to look at our coverage, there's a coverage map there as well that you can look to. And then there's a couple of links there. You can either access our support team or our sales team as well. You can send a link and we'll reach out as soon as we can.
Awesome. Peter's also on LinkedIn. He doesn't get his own special website, but he's also on LinkedIn. So feel free to hit him up. Yeah.
Feel free to ask me any questions or send me something. If you're interested in something, absolutely reach out to me. I can chat for hours on any of the GPS, GNSS systems. I can bore you to death for days. Not a problem.
I can promise he can chat for hours. I'll tell you that. All right. Thanks for being here today, you guys. And we look forward to seeing you on our next event.
Thank you very much, everybody.
Yeah, thank you, everyone.